Let's see if we can calculate the definite integral from 0 to 1 of x squared times 2 to the x to the third power dx. And like always, I encourage you to pause this video and see if you can figure this out on your own. So I'm assuming you've had a go at it, and so there's a couple of interesting things here. The first thing, at least that my brain does, is says, well, I'm used to taking derivatives and antiderivatives of e to the x, not some other base to the x. So we know that the derivative with respect to x of e to the x is e to the x, or we could say that the antiderivative of e to the x is equal to e to the x plus c. So since I'm dealing with something raised to in this particular situation, something raised to a function of x, it seems like I might want to change the base here. But how do I do that? Well, the way I would do that is re-express 2 in terms of e. So what would be 2 in terms of e? Well, 2 is equal to e raised to the power that you need to raise e2 to get to 2. Well, what's the power that you have to raise e2 to get to 2? Well, that's the natural log of 2. Once again, the natural log of 2 is the exponent that you have to raise e2 to get to 2. So if you actually raise e to it, you're going to get 2. So this is what 2 is. Now, what is 2 to the x to the third? Well, if we raise both sides of this to the x to the third power, 2 to the x to the third is equal to, if I raise something to an exponent and then raise that to an exponent, it's going to be equal to e to the x to the third times the natural log of 2 So that already seems pretty interesting. So let's rewrite this. And actually, what I'm going to do is let's just focus on the indefinite integral first, see if we can figure that out, and then we can apply, and then we can evaluate the definite ones. So let's just think about this. Let's think about the indefinite integral of x squared times 2 to the x to the third power dx. So I really want to find the antiderivative of this. Well, this is going to be the exact same thing as the integral of, so I'll write my x squared still, but instead of 2 to the x to the third, I'm going to write all of this business. And let me just copy and paste that. We already established this is the same thing as 2 to the x to the third power. Copy and paste, just like that. And then let me just close it with a dx. So I was able to get it in terms of e as a base. That makes me a little bit more comfortable, but it still seems pretty complicated. But you might be saying, well, okay, look, maybe u substitution could be at play here. Because I have this kind of crazy expression, x to the third times the natural log of 2. But what's the derivative of that? Well, that's going to be 3x squared times the natural log of 2, or 3 times the natural log of 2 times x squared. Well, that's just a constant times x squared. We already have a x squared here, and so maybe we can engineer this a little bit to have the constant there as well. So let's think about that. So if we defined this as u, so if we said u is equal to x to the third times the natural log of 2, what is du going to be? Well, du is going to be, well, natural log of 2 is just a constant, so it's going to be 3x squared times the natural log of 2. And we can actually just change the order we're multiplying a little bit. We could say that this is the same thing as x squared times 3 natural log of 2, which is the same thing, just using logarithm properties, as x squared times the natural log of 2 to the third power. 3 natural log of 2 is the same thing as the natural log of 2 to the third power. So this is equal to x squared times the natural log of 8. So let's see. If this is u, where's du? Oh, and of course, we can't forget the dx. This is a dx right over here. Dx, dx, dx. So where is the du? Well, we have a dx. Let me circle things. So you have a dx here, you have a dx there. You have an x squared here, you have an x squared here. So really all we need here is the natural log of 8. So ideally we would have a natural log of 8 right over here. And we could put it there as long as we can multiply by a natural log of 8 as long as we also divide by a natural log of 8. And so we could do it like right over here. We could divide by natural log of 8. But we know that the antiderivative of some constant times a function is the same thing as a constant times the antiderivative of that function. So we could just take that on the outside. So it's 1 over the natural log of 8. So let's write this in terms of u and du. This simplifies to 1 over the natural log of 8 times the antiderivative of e to the u, that's the u, du. This times that is du. And this is straightforward. We know what this is going to be. This is going to be equal to, so let me just write the 1 over natural log of 8 out here. 1 over natural log of 8 times e to the u, times e to the u, and of course, if we're thinking in terms of just antiderivative, there would be some constant out there. And then we would just reverse the substitution. We already know what u is. So this is going to be equal to, the antiderivative of this expression is 1 over the natural log of 8 times e to the, instead of u, we know that u is x to the third times the natural log of 2. And of course, we could put a plus c there. Now, going back to the original problem, we just need to evaluate the antiderivative of this at each of these points. So let's rewrite this. So given what we just figured out, so let me copy and paste that. This is just going to be equal to, it's going to be equal to the antiderivative evaluated at 1 minus the antiderivative evaluated at 0. We don't have to worry about the constants because those will cancel out. And so we are going to get 1. Let me evaluate it first at 1. So you're going to get 1 over the natural log of 8 times e to the 1 to the third power, which is just 1, times the natural log of 2. Natural log of 2, that's it evaluated at 1. And then we're going to have minus it evaluated at 0. So it's going to be 1 over the natural log of 8 times e to the, well, when x is 0, this whole thing is going to be 0. Well, e to the 0 is just 1. And e to the natural log of 2, well, that's just going to be 2. We already established that early on. This is just going to be equal to 2. So we are left with 2 over the natural log of 8 minus 1 over the natural log of 8, which is just going to be equal to 1 over the natural log of 8. And we are done.